All right, friends and neighbors, welcome back to another CCNA networking video. This time we are working on Volume 2, Chapter 7, Implementing DHCP. Now, if you've been following along with all the videos, you may recognize this topic as one that we saw in Volume 1, Chapter 19, IP Addressing on Hosts. In fact, the chapter is almost exactly the same as that one was, including the "Do I know this already?" questions. So we're going to review a couple of things and go over some key ideas because, well, security is upcoming, and one of the parts of Layer 2 security is DHCP snooping. So our key topics for this one: network fundamentals, identify IP parameters for the client OS, and then IP services, explain the role of DHCP and DNS. So we'll talk a little bit about that, and configure and verify DHCP client and relay. And then we'll finish up with the "Do I know this already?" questions. So as I was saying, these key topics are very similar to the previous chapter, right? So we've got some definitions for us, the special IP addresses used in the DHCP process, 0000 and all 255s. We want to go through how we set up DHCP relay, and that'll be with the IP helper. And then how do we build that in a configuration? We'll talk a little bit about where relay agents exist and the importance of the router in that scenario. And then coming up, we're going to go over the switch commands that are associated with DHCP as well. So we can also do DHCP on a particular interface. We can run DHCP relay from a particular interface, and then we can do snooping on an interface. And then we'll transition to the host settings, right? So no matter what operating system you're dealing with, you got to have DHCP settings, and that includes, at a minimum, things like the gateway, IP address, mask, and DNS. And we'll talk a little bit about the configs for the major operating systems. So a good question is, if we already did this in Volume 1 and another chapter, why do this again? Well, now we're working through security topics. And so previously, we were doing this in the context of building a small self-contained network. And in that context, well, we go through what are the host needs, and then what do we go through on a router to get the IPv4 connectivity working. And certainly DHCP is part of that. Well, now we're going to be working through the security issues, and we already talked about port security. And the question is, how can we secure things a little bit better given that we have these protocols that are running on the network? Now, one of the problems with DHCP is that it's horribly insecure because it gives out all the information on your network. The minute somebody grabs a DHCP address or a DHCP offer, they know everything about your network. Servers, IP addresses, routers, DNS, file servers, the whole thing. So DHCP is inherently insecure. And so the next chapter will tackle some of these, and we'll begin with DHCP snooping. Now, since along with DHCP snooping, we're also going to be talking about ARP inspection. ARP is also one of these broadcast protocols, and you can learn everybody with a little bit of snooping or sniffing on ARP traffic. It wouldn't hurt to do a little review of ARP as well, rolling into that chapter. So take a look at that stuff, and I'll link those in the show notes. Now, understanding the dynamic host configuration protocol is sort of critical. So it's really, really important part of our network infrastructure. Every single network uses it if they don't want to deal with static configurations. And of course, on small to medium-sized businesses, enterprise-scale businesses, they all run DHCP. So almost every single node receives its network configuration via the dynamic host configuration protocol. And at a minimum, we've got those magic 4 that we deal with, right? Our IP address, our mask, our gateway, and then DNS. So that's our basic configuration. That's where we start. And then if you've got other servers or services out on your network, you also give those out via DHCP. Now, it's very common to have a free range of addresses called a DHCP pool. But it's also very common to have reservations based on your MAC address. And so when you make a request to get an IP address, The server looks up your MAC address in its configuration and gives you out the same IP address for your MAC address. Now, the free pools are used to service guests or to handle mobility, right? Wireless nodes, IoT nodes moving in and out of the network can get an address from the free pool. Now, an important part of this chapter is the idea of DHCP relay. Normally, because of the addressing that we're dealing with, a DHCP server has to reside on the network for the hosts that are making their requests. But if we configure a router to serve as a relay agent, then we can have DHCP servers outside of your network. And the important idea there is that you could have a single DHCP server serving multiple subnets. So you don't need a whole bunch of servers sprinkled all around your networks. And the command that allows us to do the relaying is the IP helper address. So IP helper and then whatever the address is going to be for the DHCP server. So every client, when they come up and they need to get an IP address, they go through the same process. It's called the DORA process for a discover, offer, request, and acknowledgement. So the discover is from the client to the server. Actually, it's from the client to broadcast, and the servers are just waiting for these requests to go out there. So the client sends out a discover message to a broadcast address, and you can see that in the captures here. The initial address is 0.0.0.0 for all clients, and this is an address that's reserved for this particular process. And the discover goes out to 255, 255, 255, 255. And so this is a broadcast address, but it's a broadcast on this network only, right? Whatever network you're sitting on. Now, if there's a server there, then the server opens this up because it's a broadcast and recognizes it as a DHCP discover. Failing that, there might be a relay agent there that does the same thing. Now, the DHCP offer comes back from the server, but it's also going to the broadcast address because the client doesn't have an IP address yet. So it's got to use the broadcast address. And then the client comes back with a request. Option number 3 or message type number 3 in the DHCP is this request. And this is the client saying, yes, I thank you for your offer. I would like to have that address, please. And then the last message is the server acknowledging that the client is going to take that address. Now, after this point, the client and server will communicate using the unicast address that was offered to the client. So now you can see why we call it the DORA process, and we can see which directions they go in. So a little bit more about those special addresses. 0.0.0.0 is reserved for hosts that don't have an IP address. Now there's one other place that we see this is in a default gateway line in a routing table. These are two different things. So one is an IP address that you would actually see in an IP packet, and one is a routing table entry. The local broadcast address of all 255s is not forwarded by routers. It's for broadcast on a particular network. The other kind of address is a directed broadcast that includes the prefix for the subnet and then 255 or all ones in the host portion of the address. Now, another thing we have to remember is with DHCP or with automatic configuration of hosts, sometimes hosts don't get an address via DHCP, right? They're looking for one, but if the DHCP server doesn't answer, or there's a problem, or you just want to do automatic configuration by the hosts, then we can do what we call a PIPA addressing or RFC 3927 dynamic configuration of IPv4 link local addresses. Now there is a range of addresses that are reserved for this process. The commonly used prefix is 169.254.00/16. The actual range of addresses specified in the RFC 169.254.1.0 to 169.254.254.255. And what this means is that if there's no answer from a DHCP servers, the host will automatically select an address in this range for themselves. This will allow them to communicate with other nodes that have also gone through the PIPA process. So servers listen for host requests or discover messages that go out at the 255, 255, 255, 255. And then they respond with the offer. Now there's a couple of details here. When a server gives out addresses, the server has to keep track of the addresses that it's given out, the MAC addresses to which that address was given, and then what we call the lease time, how long those addresses are going to be retained by that host. Now you may have wondered, what if there's a whole bunch of hosts and they're all using 0.0.0.0 for their source address, and they're all using broadcast addresses as the destination? How does the server keep track of all of the addresses that are given out, right? Initially, everybody's using the same thing. And the answer is that all of the messages within the DORA process have something called a transaction ID. And the transaction ID is the same for all of those messages. So each host will have a different transaction ID to keep its messages together. So back to DHCP relay. When you're building a whole bunch of networks and connecting them together, you have a choice. You can put a DHCP server on every single network or subnet and dedicate all of those resources to all of those servers. Or you can have a couple of servers, maybe centrally located, and then set up DHCP relay to forward all of those requests to the servers. This is what most large organizations do. So the routers serve as the relay agent and they forward traffic to the server. So if we take a look at the diagram here at the bottom of the slide, PC1 says, I need to get an address, and the router is acting as a DHCP relay and forwards these requests into the DHCP server. Now, when this happens, there's a change to some of the fields, right? So we know that a router will be acting as a relay agent, so that's indicated in the DHCP packets. Some of the addressing is slightly different too than the standard DORA process. Now, another fun thing is that in addition to acting as a DHCP relay agent, you can actually build a DHCP server on a Cisco router. So instead of sending it to a virtual machine or a hardware box that's configured as a DHCP server, you can just use a router as your DHCP server. So we're going to do a demo now. Now this demo will be the same one that I did for the previous chapter, but it's an important demo because it does all of the main components of this chapter. So on to our demo. Now I'll try to explain the steps as I go and make sure that we understand exactly what's going on. But the first thing that we'll do is we'll take a look at this host. Now this host is set up as a DHCP client, just like the router is. Usually in Packet Tracer, we just use static configurations, but let's set this up to be a DHCP server and client situation. All right, so if you're on the router and you want to set up a DHCP server, now I've already set it up, but I'm going to do the steps anyway so that you can see. First, I'll show you the config. Do a show run here. And you can see that I have this pool of addresses. Now, in keeping with the idea that there are four main numbers that we need, right? IP address, mask, router or default gateway, and then our name server, we're going to make sure that we give out all of those to our host. So we'll make sure that we add whatever we're missing here. The other thing is that we're going to make sure that we tell the server, look, if there are special addresses that you don't want to give out, then we need a line or a config of some kind that says, don't give those out. Now, importantly, your DHCP server has to have an IP address on this particular network. So this is the 172.16.1 network, and I think that's the same as the one that is in the book. And so my router has an address on that network. That's really important. And that's pretty much all there is to this config. So again, if I was going to work my way through it, I would say config T, and I would say IP DHCP pool, and I just called it the 16net. Now, I know that my address, my interface right here is 172.16.1.254/24. So when I see what my options are for my DHCP server, I have to give out addresses that are on that network. So I would say network. Well, what's the network? 172.16.1.0. And I'm going to give out addresses on that particular network. So that's the network. Now I don't have to specify the mask. So that's 2 out of 4, right? I've got the IP address and the mask, because the mask will come along with what I've specified right here. And now I'm going to say, well, my third one is the router. So you can see I've got a default router command. And as the default router, I'm going to use, well, let's see. Since this is just the server, I'll go ahead and specify that your default router is going to be 1.253. So that'll be right here so that we can communicate. I have to remember that we're not acting as a DHCP server here. So maybe what I'll do is make sure, because I configured this before, and I'll make sure that we're not going to give that other one out. So we'll do that. Okay. Now, the other thing that I need is a name server. So we need a DNS server. Now I don't actually have one in this topology. Normally you would, right? But this is just a little packet tracer topology. So I'll go ahead and say that the router or my DHCP server is also my name server. Okay, now I could make something up, and maybe we will. Maybe we'll make something up. We'll say DNS server 8.8.8.8. Okay, so what we should be able to see is this in our packet transfers. So that is what we need to do to have our DHCP server running. And just to be complete, let's take a look at it. Oh, it got rid of, see, it's a good thing we looked. It got rid of my default router. So I'm going to go ahead and put that in there. The minute I did no default router, it got rid of it. So we're going to say default router 172.16.1.253. Now let's take another look. There we go. That looks a little bit better. We have our network. We have our default router, our DNS server. We've got this other pool that we haven't done anything with, and then we've got this excluded address. And the reason I added this, because I do not want to give out the address of the router to one of my hosts. So that's why that's there. All right, let's see the behavior of our host. And this also shows us one way to take a look at the host's IP address. So I can do this. I can say ipconfig, and this gives me some level of understanding. But this is old information. So what I might do is take some of the options here, and I might say release. Oops, maybe it doesn't like that. There we go. So we're releasing the information that we had, and I'm going to turn on the simulation now. And now we're going to say renew. And we can see right here, right, the client has said, I need to renew my information. Now this will look a little bit different than DORA, because a release and renew is different than the startup. But if I take a look at this, it's going to ask for its address to begin with. Let's see how Packet Tracer implements this. So we've got all of this zeroed out. So I got rid of the address that I had. Now this host also doesn't have a reservation. It's working from the free pool of addresses. Okay, so it looks like the way they've got it set up in Packet Tracer, we're going to do a complete reconfiguration. All right, so let's see what happens next. This goes out to the switch. Now remember that if we look at, I guess I should have pointed this out. If we look at the addressing here, the source IP address is all zeros, and there's our broadcast. So the reason that the router finds this is because it goes out everywhere. So it goes blasted out everywhere. Our DHCP server opens this up and says, I got you. Now we got some ARP stuff to do. There we go. So this should be an offer that comes back. And again, we're still using our layer 2 broadcast, our layer 3 broadcasting back, but this will be back to the MAC address of the host. And what the server is saying is that I'm going to offer you this particular IP address if you like it. The client comes back and says, again, still using the broadcast addressing, but it says, you know, I'd like to I'd like to go ahead and request this if I could. And we've got the server coming back now, and this should be straight up the acknowledgement that says after this point, you go ahead and then use the one that you want, or use the one that's been offered. Okay, so at this point, we're done with DHCP. Now, if we take a look at our ipconfig commands, now this is actually part of troubleshooting. If I was having trouble with this host, or I just wanted to verify some things, I could do a simple ipconfig command, and I could see that I have an IP address, I've got the right mask, and I do have a default gateway here. If I do ipconfig/all, I can get more information, than I did before. There's my DNS. So these are all the things that I had in what's called my DHCP pool. And so this is some basic troubleshooting that I would use to test my host. And I can also test connectivity to my default gateway now. I can say, well, can I touch my default gateway? And I can. So life is good for this host. Now, while we're here, I just also wanted to point out that there's nothing at all that says that a router or some other network device can't be a DHCP client as well. If I do a show int f0/0, I think is the IP address, we can see that we're up, right? So we have link and the interface is not shut down, but we have no IP address here. If I don't want to configure an IP address, or this is an IP address on an interface that's connected to a service provider, what I might do is say interface f0/0 IP address, right? What are my options here? I might say, just give me a DHCP based address. Now, I don't think I was fast enough to do the simulation, but we can see right here that it pulled a .2 address from the DHCP server. So now if I say show int f0/0, I can see that I've got an IP address here, and that came from my DHCP server. In fact, a lot of times it'll actually say that this was a DHCP client. So that takes care of everything sort of on this side, right? If I sort of draw a line, that's everybody on the 192 or 172.16.1.0 network. But what about this host over here? It needs an IP address. Now for that, we need to configure the IP helper address because there's no server on the 2net. Let's take a look at this router's routing table. And we'll see one of the questions is, well, how do you know where your helper address ought to be? And the answer is that I need to know where the clients are, and I need to know that there's no DHCP server over here. So what I'm going to do is set up that helper address. Now on the IP helper address, we're not actually giving the address of the interface, we're giving the address of the DHCP server. So now we'll go ahead and we'll start the simulation again. And I'm going to go into this host's configuration. And I'm going to say, I want you to be a DHCP client. And we can see the minute I do that, right, there is this DHCP request that goes out. Now on this side, it is the standard DORA behavior that we're used to. But what's going to happen now is that the DHCP relay agent will see the request after all this ARP is done and forward it out to the server. There it goes. So now we can see on this side, right on the 1net side, it's no longer broadcast. This is between these two IP addresses, the helper address and the router interface. So that is what's changed now. And so what we will also see is that now we've got this relay agent here that has an IP address that's different than the DHCP server. Now, the relay agent is working, but of course what we've forgotten to do is set up that other scope. So good practice for us. Let's do that. And I'm going to say config t IP DHCP pool 16.2 net. Well, what's the network there? Well, it's 172.16.2.0, 255.255.255.0. Well, we need a default router, 172.16.2.254, I think, is where it is. And then we'll do DNS 8.8.8.8 again. Now, the other thing that we'll now do is, because we don't want to give out the address of the router, I'm going to say IP DHCP excluded address 172.16.2.254. Okay. We take a look at our running config real quick. Now we have two scopes. They look very, very similar. We've added our excluded address. Now, one fun question is, how does the server know which network address to give out to a client? And the answer is, what is the IP address of the helper address that we see in DHCP? And once it sees that, it goes, oh, you're coming to me from the 2net, I'll give you an address over here. Well, let's see what's going on here. Now the host sends out this DHCP request. It goes out from the relay agent and goes up to the server, and there's our DHCP address coming back. Now, if I take a look at my host, right, initially, with no DHCP server, before we configured the pool, we got this 169, or an APIPA address. The nice thing now that we've got this, let's go back to real time. If we take a look at this now, oops, we're not on a router. If I do an IP config here, we now have an address on the 2net. And there we go. That is DHCP relay. Now, every once in a while, I suppose I'll show you two other things. Every once in a while, you need to help a router figure out where the other networks are. So that's what this command is there for. Right? Where is the 2net? Where are the hosts that I'm serving up? So be wary of that. And the last thing that I'll show you here is also one of the questions. If I do a show IP route, take a look what we have right here. We now have not only an IP address given to us by the DHCP server, but we have a default route. And that is because the DHCP server gave me a default route or a default router that I configured into a default route. Well, now I've got these two clients on either side of this router. A real test would be whether or not I can ping between them. And there we go. Everything works. So I built two pools, two sets of clients, and an IP helper address serving as the DHCP relay. All right, so let's remind ourselves about some of the important host details. So now that we've done the demo and we've talked about the addressing, we see that addresses come to the host, and whether you're statically configured or DHCP configured, you need four basic details. You need an IP address, you need a mask that indicates your network, you need a default gateway to get off of your network, and then you need a DNS or a name server that helps you resolve addresses out there in the internet or even in your own organization. So the whole point of DNS is to map names to IP addresses. The most common lookup is called a forward lookup, where you say, I need this service or this web page, right? This URL or URI. What is the IP address that goes along with it? You can also do a reverse lookup, which says, I already know the IP address, what's the host that goes along with it? Now, with these four numbers, you can get anything done. If you're missing anything, you're very restricted, right? If we're missing a gateway, we can't get off the network. If we're missing DNS, we have to use IP addresses to do anything. Most people don't remember IP addresses. Remember that the mask that you use is going to be the same as your router. When we're working with different OSs, the key is getting the information is sometimes obtained by GUI, sometimes it's obtained on the command line. And there are different commands to do all of these. So in a Windows, you're going to do ipconfig. In Linux or a Mac OS, you might be doing ifconfig, netshow, and netstat. Netstat especially is cross-platform, so you'll see that in a lot of different places. Now, troubleshooting thoughts. If you're having trouble getting something done, a really nice thing to do is just simply check to see if you've got an IP address. Now, we start with a link light, right? Do I have a link light? And if I do, did I get an IP address? And what is the IP address? Does it match what I've previously known from my IP addresses on this particular network? Sometimes, if you know the network configuration and you haven't got an address, you can statically configure things and then test connectivity to the router, to neighbors, and then to the internet. You can also try tools like NSLookup to see if you can do DNS forward or reverse lookups. So don't panic immediately if you can't get off the network somewhere. All right, our Did You Know This Already quiz. Question number 1. A PC connects to a LAN and uses DHCP lease on an address for the first time. Of the usual 4 DHCP messages that flow between the PC and the server, which ones does the client send? Well, we know that right off the bat. It's the discover and then the request after the server comes up with an offer. Question number 2, which of the following kinds of information are part of a DHCP server configuration? Well, we just configured that, so we know that we're going to give out the network or the IP addresses to lease, and then also the addresses not to lease. These are the excluded addresses. Question number 3, which answers list a criterion for choosing which router interfaces need to be configured as a DHCP relay agent? Well, we have to make sure that the subnet off of the interface has DHCP clients, but there isn't a server there. So that was A and C. Question number 4, a router connects to an internet service provider using its gigabit interface. With the IP address DHCP command configured, what does the router do with the DHCP learn default gateway? Well, we just saw that it adds a default route. In the following excerpt from a command on a Macintosh computer, which of the following parts of the output represent information learned from a DHCP server? Well, if we think about what we just configured and we think about the basics, we know that we need the IP address and the mask will have come from the server. All of this other stuff is interface specific or automatically figured out. Question number 6, which of the following commands on a Windows OS would list both the host IP address and DNS servers IP addresses as learned with DHCP? We saw that was ipconfig/all. All right, our Chapter 8 look ahead. So we're dealing with more Layer 2 security measures, right? We just got done talking about security architectures and then port security. And now we're going to deal with DHCP snooping and ARP inspection. This is why it's good to go over these topics again. And I'll add links to DHCP and ARP operation in the show notes. We'll be talking about examining traffic, understanding the processes, trusted and untrusted sections of the network, and then the logic behind these security tools. That is to say, how they work and what are they looking for, given that we now understand something about DHCP messaging and ARP messaging. Okay, this has been all about implementing DHCP. Remember that the big 4 numbers that you need, no matter what network you're on, will be the IP address, mask, gateway, and DNS. Gateway is another name for a router, of course. We talked a little bit about how DHCP works and DHCP relays, or IP helper addresses. Like and subscribe for the DHCP snooping and ARP inspection coming up. May those packets always reach their destination, which means that you'll have those magic 4 numbers in there. And hey, this is CCNA. We're doing security. We're doing DHCP. You can do this.